3.4 is where we start to talk about our congruence postulates. And the congruence postulates are just ways that we can determine if triangles really are congruent. Remember, congruent means that they are equal, they're the same size. And so if you have one triangle with the side lengths of 4, 6, and 8, and you need to draw a second triangle that is congruent to the original, how long should its side be? Well, if they're congruent, that means their sides are equal, so the sides of the other one should also be 4, 6, and 8. And it asks if you can build two triangles that have the same side lengths but are not congruent. That is a false statement. That is not possible. If you build two triangles that have the same side lengths, they will always be congruent. So two triangles with the same sides lengths will always be congruent. They will always be congruent. So there's a couple of postulates in math. Postulates are they're going to be kind of like definitions, and they tell us things about shapes, and if these things are true, then that means other things are true. So the first postulate we're going to talk about is the SSS postulate. The S's in SSS stand for sides. So when it says SSS, it's the side, side, side postulate. States that if the sides of one triangle are congruent to the sides of a second triangle, then the triangles are congruent. And that's what it was telling us up here, that if I have one triangle with sides of 4, 6, and 8, then my other triangle that's congruent has to be 4, 6, and 8. So if you're trying to prove that something is true by the side, side, side postulate, the SSS postulate, then what should happen is that the three sides of one triangle should be congruent to the three sides of the other triangle. So the question asked me, which of the two sets of triangles below demonstrates the SSS postulate, or the side, side, side postulate? Well, if I look at A tells me that DE and AB are congruent. It tells me that EF and BC are congruent. And it tells me that DF is congruent to AC. So since these sides were congruent, and these sides were congruent, and these sides were congruent, all three sides were congruent, so A is true by the side, side, side postulate. So moving on to page. The SAS postulate. Well, using some common sense, you can probably figure out the S stands for side. Hopefully you can use some common sense thinking, if I know something about triangles, triangles have angles and vertices, so the A has to stand for angle, and the last S again stands for side. So the side angle side postulate, the SAS postulate, states that if two sides and their included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the triangles are congruent. So let me give you a picture. I have two triangles. In order for the side angle side postulate to be true, then what has to happen is I have to have sides that are congruent. So I've labeled those in green. And then I have to have another side that's congruent. I'm going to label those in blue. And then it says here that the two sides and their included angle what the phrase included angle means is the angle that's in between those two sides, or the angle that connects them. So if you look at these two triangles, the angle that's in between those sides is this angle here at the top. So in order for the side angle side postulate, or the SAS postulate, to be true, you have to have in a row a side, an angle, and a side. And again, a side, an angle, and a side. They have to be connected. So we have this example down here, this question of A and B. It says, which of the two sets of triangles below demonstrates the side angle side postulate? So that means I should have two sides and the angle in between them. So if I look at A, well, it tells me that FO is congruent to AB. It tells me that 36 and 36, my angle A and my angle F are the same. And then I know that FX is congruent to AC. So I have two sides and the angle in between them. So that means the answer A is true by the side angle side postulate. So what I know now is because those two sides and those angles are congruent, that means that my triangles are congruent. Okay? So these two triangles are congruent to one another. That means all of the sides are actually congruent. And the way we proved that was by the side angle side postulate. Now, I want you to look at B, and let's see what we notice about B. Well, we notice that BC is 5. And we notice that EF is 5. It also says that AC is 10 and DF is 10. And it says ED is 9, and it says that AB is 9. So because I have 3 sets of congruent sides, this one is true by the SSS postulate, the side, side, side postulate. Moving on to 12, you can probably figure out what the ASA postulate stands for. ASA stands for angle, side, angle. So the ASA postulate states that if two angles and their included side, so two angles and their included side of one triangle are congruent to, I'm going to draw an arrow to this box because I don't have enough space to write it, but it should say the same thing. So if two angles in their included side of one triangle are congruent to two angles in their included side of another triangle, the triangles are congruent. So giving you a picture what that looks like. Here's triangle 1, here's triangle 2. So this says two angles. I'm going to pick two angles. Their included side means the side in between them. So this side right here. Okay? That's what the ASA postulate says. If the angle, the side right next to it, and the angle right next to that are congruent in two triangles, then both those triangles are congruent. So everything else there is congruent. So it says, which of these two sets of triangles below demonstrates the angle side angle postulate? Well, if I look at A, I can't see B yet, so I'll go there in a second. But if I look at A, I'm trying to determine if it's going to be true by the ASA postulate. First thing I notice is this says angle, side, angle. That means I should have two angles in one side. If I look at A, I don't have two angles in one side. What I have is a bunch of stuff. I have two sides, but that doesn't really even mean a whole lot. So let's see what we've got in this one. We know that 9 is congruent to 9. We know that 8 is congruent to 8. And we know that 29 is congruent to 29. But if we look at where these are placed, they're not in the same place. The 8s are in different places. The 9s are in different places. The 29's in the same place, but that's about it. So these two are not even congruent at all. If they were going to be congruent, those numbers would have had to have been in the same place. So we're going to go on to the next one. And we have two triangles. And we're going to figure out what we know. So let's start with what we have, the 92. So they both have a 92-degree angle. They both have 2 marks on XZ and RT, which means that those two are congruent. And because they have this symbol right here, what that means is those angles are congruent. So based on this picture, I have an angle, a side, and an angle. An angle, a side, and an angle right in a row. So these two triangles are congruent by angle, side, angle. Because they have 2 angles and the side in between them are congruent. Alright, the AAS theorem. Hopefully you can figure out that this stands for the angle, side theorem. States that if 2 angles and the next side are congruent to the corresponding 2 angles, and the next side of another triangle, and the triangles are congruent. So notice this time that I'm going to have an angle, then the next angle, and then the side right after that. Okay, so the side's going to go angle, angle, side in a row like that. So in giving you a picture of what that looks like, if these were my 2 triangles, I would know these 2 angles were congruent, these 2 angles were congruent, and then this side was congruent. So in a row, it's angle, angle, side, angle, angle, side. So looking at the picture, what we have here, A gives me an angle, then it gives me a side, and then it gives me another side over here. And again, I have an angle, a side, and then another side. That's not the same thing as angle, angle, side. So let's look at B. B gives me the angle up here at the top. It gives me the angle down here, X and R. And then it tells me that the side XC is congruent to RT. So B is true by the angle, side postulate. So the question next asks if there is a possibility of there being a side-side angle postulate. And the answer is false. You cannot have a side-side angle. If it helps you to remember it, think of side-side angle spelled the other direction. It's a bad thing. We can't have that. The other thing it asks is if you can have an angle, angle, angle. And that one is also false. Angle, angle, angle is bad. So here's our 4 postulates. We're going to list them on the next page. Find some space. Here's our 4 good ones. We have the side, side, side. We have the angle, side, angle. We have side, angle, side, and angle, angle, side. The bad ones, these are the ones that are not actually going to work, is the side, side angle, and the angle, angle, angle. The good ones determine congruence, the bad ones do not. So I have these 4 pictures here, and I'm supposed to determine which of these 4 postulates, the good ones, match each of these 4 pictures. So let's start with the bottom one. Let's see what we've got. We have the 39 and the 39, which is an angle. we have the 64 and the 64, which is an angle, and we have the 7 and the 7, which is a side, so this one is the angle side postulate. Look at the next one. I have the 100. I have the 22. The 100 was an angle. The 22 was a side. And the 35 is the next one, and it's an angle, so this is the angle side angle postulate. Look at the next one. I have the 9, which is a side. I have the 62 that's the same in both, which is an angle. And I have the 17 that's the same in both, which is a side. So this one is true by the side angle side postulate. Look at the last one. I have a 9 and a 9, which is a side. I have the 10 and the 10, which is another side. And I have the 5 and the 5, which is another side. So this is the side, side, side postulate. For 1 through 4, we're supposed to determine which congruence postulates or theorems could be used to prove that these two triangles are congruent. So again, that goes back to our four good ones. Side, 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 angle, side, angle, angle, side, angle, angle, side. So looking at number 1, figuring out what they've given me, I have a 9 and a 9, which is a side. I have an 8 and an 8, which is a side. And I have an 11 and an 11, which is a side, so this is the side, side, side postulate. Number 3, I have an angle of 42. I have an angle of 85. And I have a side of 5. So this is true by the angle side angle postulate. Alright, number 5 says what else would be needed to prove congruence? What else would need to be congruent to show that triangle ABC is congruent to triangle DEF by the angle side? First thing I notice here is I'm going to look at what they gave me. They gave me a side. They gave me an angle. So in order for this to be true, I have a side and an angle. I'm going to have another angle. That's for sure. So the question is it angle A and D or is it angle C and F? Well, let's figure it out. I'm going to write an A up here. You don't have to do this. If I did that, then this would be the angle side angle theorem. That's not what I want. I want angle side. So having the angle at A won't help me. If I had the angle at C, though, then in order it would be angle, side. So I would need to know that angle C was congruent to angle F. Number 7, what else would need to be congruent to show that triangle ABC is congruent to triangle DEF by SSS. Remember, SSS stands for side, side, side. So this should be easy. Here's my picture. Well, in order for these to be congruent by side, 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 I have to know that all my sides are congruent. They gave me one set of sides, 7, the A sides, AB and sides DE. They gave me another set, BC and EF. So in order for this to be true, then AC is going to have to be congruent to DF. And if they're congruent, then the side, side postulate will be correct. Number 9, what else would need to be congruent to show that angle ABC is congruent to angle DEF by angle side? So let's look at what we've got. We have this angle A. They've told us angle A and angle D are congruent, so there's my angle. They've also told me that side AC is congruent to FD, so there's my side. So I need another angle, that's for sure. The question is it angle B or is it angle C? Well, if it was angle C, then this triangle would be angle, side, angle, and that's not what I want. I want angle, angle, side, so it's going to have to be angle B, and it's going to have to be angle E. So I would need to know that angle angle B is congruent to angle E.